Warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, pencil, or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a little bit more pre-calculus review for some of those of you in calculus. It's crucial that you know how to solve trigonometric equations. Crucial. And solving trigonometric equations requires you to remember the trig inverse rules. That is, the sine inverse rule, the cosine inverse rule, and of course the tan inverse rule. So these three problems are designed to just have you consider the interval from 0 to 2 pi, that's just like the basic unit circle, and think about how to solve these problems. Now, one of them has a star on it. It's not really as difficult as it needs to be. I guess I just mean that there's something kind of extra going on there that I'm going to show you. It's sort of a different method, different way of looking at the problem. So go ahead and take, I don't know, I think this should probably take you like 12 minutes if you're being pretty fast. But if you want to be very careful about it, take your time. Just want to make sure you know how to get these answers. Because if you don't know if you can do it, then that'll be your first place to improve. If you can do it, it's just slow, then you can improve your time later. As long as you know what you're doing, then you can improve the speed. Okay, so give yourself some time to try it. Then when you're ready, unpause the video. See how we get it here. I'm going to separate these first, just to give some space. They look really nice pushed together, but I'm going to move this a bit. Let's start with this one here. It's not very difficult to get the sine expression by itself and get sort of towards the end of the problem, so we just use basic algebra to say that 4 sine squared equals 3, and therefore sine squared is 3 over 4. Now, a couple of things come into play here. First of all, when you take a square root to solve an equation, you always have to consider plus or minus. So sine x equals plus or minus square root of 3 over 4, which is square root of 3 over 2, because the 4 was in the square root. But we can just call it 2 and take it out of the square root. So this gives us two different equations. One of them is sine x equals rad 3 over 2, and the other one is sine x equals negative rad 3 over 2. Now this is not the sine inverse rule, not yet. The sine inverse rule comes into play. This is the second thing I wanted to mention. When we finally try to calculate the angle. So we say x equals the sine inverse of square root 3 over 2. But the sine inverse rule says that we take theta as an angle, and we also take pi minus theta as an angle. The way you can remember this, supplement sine, the supplement angle for sine inverse. Which means we're not only going to get the angle of pi over 3, we're also going to get pi minus pi over 3, which is 2 pi over 3. And this is accurate. Both of those angles have a sine value of square root 3 over 2. Now, on the other hand, we have x equals the sine inverse of negative square root of 3 over 2. Which means we also get x equals pi minus whatever that is. You should know this is negative pi over 3. But we need to consider this in the positive region. This is the same as, well, 5 pi over 3, ultimately. Right? I guess it actually works out. If you do it this way, you just get 4 pi over 3. And that's accurate. This one, however, we must call 5 pi over 3. So those are the 4 angles. And if you've studied the unit circle well enough, you would know that the square root 3 over 2 case for sine covers all of those pi over 3 angles, which is pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. Okay, so the sine inverse rule is a supplement angle. You take the angle and the supplement. Let's move on to the next problem. And I want to make some more space. Now, for this one, what shall we do here? I think it's kind of natural. If you can remember that this expression is simply cosine of 2x all cubed, you'll realize that you can factor cosine of 2x out of this, which is great. And that leaves you with 2 cosine squared of 2x minus 1. Yeah. Well, interestingly enough, if you remember the double angle formula, this turns into something nice. How is that? Well, one of the double angle formulas for cosine, and I think I'll do this off to the side left. Cosine of 2 theta, one of these forms is the following: 2 cosine squared of theta minus 1. But if we sort of double the angles, if we sort of upgrade everything, so now we have 2 cosine squared of 2x, or 2 theta, that should be the same as cosine of 4 theta, right? We've doubled things. That's exactly what's going to happen here. So this is simply cosine of 2x times cosine of 4x equals 0. And that's potentially a little bit easier than solving it with this quadratic. I'm not saying it's better, but it does look more condensed, doesn't it? In my opinion, it's a little bit simpler to solve from here. So we use, of course, zero product property, that doesn't change. To make each of these equals to 0, when does cosine equal 0? When does cosine of 2x equal 0? The angle would have to be pi over 2, right? That's the cosine inverse. But the cosine inverse rule says that if you take theta, then you also have to take negative theta. Think counter cosine. Counter, like the opposite, your counterpart. Right? So if you take angle theta from the cos inverse, you also have to take negative theta. Now, because this angle is in the negative, you need to turn it into a positive angle there. So that would be 3 pi over 2. What do we say? Plus 2 pi n. Now, why do we do this? We do this because if we go around the unit circle and pick up more solutions, then we need to add those to the list, as long as the x value overall is between 0 and 2 pi. So let's see how that works here. On the one hand, let's move this. We're going to have 2 sets of solutions here. If n equals 0, actually let's progress a little bit further. Let's progress just a little bit further. Pi over 4 plus pi n, we get this by dividing both sides by 2. And x equals 3 pi over 4 plus pi n. Okay, now we're ready to plug in values for n. At n equals 0, we get pi over 4, and we also get 3 pi over 4. Whereas if n equals 1, we get 5 pi over 4, and we also get 7 pi over 4. That's from both of these lists. Whoa. Running into the bottom problem, let's make more space. Okay, we found 4 solutions for that. Now let's proceed with cosine of 4x equals 0. Now this is only going to be true when 4x equals pi over 2 plus pi n. Plus 2 pi n, that is, excuse me. Which means I'm also going to have 4x equals negative pi on 2, which we can just now call 3 pi on 2. Same kind of deal as we did with the other cosine inverse. Then we're going to divide both sides by 4. And we get pi over 8 plus pi over 2n. So I think we're going to get a lot of solutions from these ones. And here we have x equals 3 pi over 8 plus pi over 2n. All right, here we go. Let's pick up some solutions. If we have n equals 0, then we get pi on 8 and 3 pi on 8. You'll see a pattern. Then when n equals 1, what are we adding? We're adding pi over 2. But if we want to put that in terms of pi over 8, we're adding, I'll put plus 4 pi over 8. That's basically what we're doing. So we end up with 5 pi over 8 and 7 pi over 8. See that? Now if we have n equals 2, we're adding another 4 pi over 8. So we're going to end up with x equals 9 pi over 8. And you can see it's pretty much just the odd numbers, right? That's really the pattern here. And we can go as far as possible until we get towards 2 pi. We cannot surpass 2 pi. So 13 pi over 8 and 15 pi over 8, and that is the final one before we get to 2 pi. So all of these angles are solutions to the equation. Wow. That means if you take a look at the graph, look at the graph of this function, it should cross to the x-axis at all of these values. Pi over 8, and then pi over 4, and then 3 pi over 8, and then 5 pi over 8, and then 3 pi over 4, and so on and so forth. Pretty wild. So to recap the cosine inverse rule, when you solve a cosine equation, you need to take theta from the inverse and negative theta, its counterpart. Great. Let's move on to tan for the last problem. This one's pretty straightforward. No crazy algebra required. Tan of 2x equals negative rad 3. Now think about when that is. When does tangent go to root 3? It's going to be a pi over 3, but because this is a negative, we're going to say 2x equals negative pi over 3. Now the trick for the tan inverse rule is that all you need to do is say plus pi n. You don't need to have 2 separate equations here. So it's really simple. We're just going to say plus pi n, and that's going to give us all of our solutions. So, of course, let's make this a positive angle, shall we? By adding pi. And then we can divide both sides by 2. I know it looks silly to say that 2x equals this negative pi over 3, and 2x also equals this 2 pi over 3. It's because n is not set. N could be a different number here as it is here. I know that looks a little bit confusing, but sorry. In fact, it's bothering me to even look at it. That makes me feel a little better. So now we're going to say x equals pi over 3 plus pi over 2n. Let's see how many different values of n we can go through. If n equals 0, then x just equals pi on 3. If n equals 1, then we're adding pi over 2. Well, we need to get common denominators now. The common denominator is 6. So we're going to be adding 3 pi over 6. It's the same as pi over 2. And pi over 3 is the same as 2 pi over 6. So this is going to give us 5 pi over 6. Now if n equals 2, add another 3 pi over 6. X equals 8 pi over 6, which we call 4 pi on 3. Getting close to the end here. N equals 3 is going to yield 11 pi over 6. And that's as far as we can go, otherwise we'll surpass 2 pi, which is 12 pi over 6. Okay, so the tan inverse rule by far is the easiest one. You just have to progress forward by pi to get your other solutions, whereas the cosine inverse rule requires you to counter the inverse value, and then the sine inverse rule is to take the supplement of the inverse angle. This should be enough to get you back on track, and if you were not able to follow along, you are in a dire situation. You need to review the unit circle as much as possible, learn the patterns of the unit circle, and your life will be much easier in calculus. Right, I think that's enough blab out of me. I'll see you guys next time.